Hey everyone, Demetrius Malbro here, back with another episode of Data Protection Gumbo. And I have a great guest lined up for us today. He is a podcast veteran here. So he has been on the Gumbo a few times now, but we just can't get enough of Stephen Umbehocker, who is the founder and CEO at OSNEXUS. Stephen, welcome back to the Gumbo.
Hey, thanks for having me, Demetrius. Great to be back.
All right. And Stephen, so we have you on because artificial intelligence and machine learning is a very, very hot topic these days. And I want to get your take on AI and ML, especially as it pertains to storage. So, first, give us some information about OS Nexus, and then we can dive into some of the exciting topics around what's happening with AI and ML and storage.
You bet. Yeah. The quick overview on OS Nexus. We've been around for a bit over a decade. We've been serving cloud service providers like IBM, but just a whole range of different industries from media and entertainment to higher education research to government and banking. Just kind of OS Nexus is a bit into every vertical. And the platform that we make, the storage platform we make, installs on standard servers. So we can turn those into appliances and then build large scale out object storage and file storage, which is really critical to the machine learning process, to the AI ML workloads.
Awesome. And so let's talk about accelerating data pipelines, especially with artificial intelligence. And also, I saw some things going on with Supermicro, and they seem to have some proven storage architectures, especially as it pertains to persistent storage. You want to give us some background on how all of that came to be?
Yeah, we've been doing a lot of work with Supermicro over the years, and there's just nowadays object storage is becoming a real performance storage tier. People are doing more and more with object storage directly with their AI ML workloads, and NVMe is getting more and more economical. So what we've been doing with Supermicro is building these really large scale all NVMe object stores and scale out file storage so that we can really provide super high performance storage to these AI ML systems. It gets really interesting. You start looking at how those workloads operate, and you get a mix of different file sizes. And you think, well, why would that matter? If I've got a bunch of 1K files and 1 gig files, it's all files, it's just data.
Yeah.
But it actually matters a lot. When you are working with really small files, they don't write out well to really long data stripes or erasure coding type data layouts. Because if you take a 1 kilobyte file and you try to chop it up into, 8 data chunks and 3 coding blocks, as an example,
Hmm.
taking the 1K, dividing it up into 11 pieces, now you have these small, super small chunks of 100 bytes roughly. And that just takes a long time. It really kills performance, and it ends up trying to write these small blocks to the media when the media is designed to write 4K blocks or 64K blocks. When you're trying to write a really small amount and striping it, having so many nodes get involved, you're just sort of like, it's like saying, hey, I need to carry this bag of groceries in, and you're getting 10 people to go carry it. It's sort of like, that is like the most inefficient way. Everybody goes and grabs like one thing out of the bag, maybe, I don't know, but it gets
Yeah.
super inefficient. And so we've been looking at ways to dynamically tag the data as it goes into the data store to put it in the right place. So when a 1K file comes in, or object as it's called when it's stored in the object store, we tag it to go into a replica based pool of storage so it can write it super fast. So it ends up making 3 copies of the data, but it's way faster to write 3 copies to 3 nodes than it would be to chop it up, compute all of the hash, run the Reed Solomon algorithm, and then send it to 11 nodes. So it's a small thing in a way, but it's super transformative, being able to dynamically tier as the data is being ingested to put it in the right spot. So
Okay.
that's one of the latest features in QuantaStore is the ability to put in these rules into the objects into the system to just tell it how to dynamically categorize the data. But it's so critical for AI ML workloads.
Yeah. So I assume that balancing high performance and also capacity optimized storage is very important, especially when you're talking large language models and you're talking being able to fetch that data and provide an answer, well, crunch that information and provide an input back very quickly. And so performance is very important.
Yeah.
Now, what I understand is that your approach also balances flash based parallel file system, high performance storage with some of the capacity optimized object storage, as you mentioned. But can you explain the decision making process behind allocating the data between these two types of storage, especially considering the differing needs of frequently accessed versus less frequently accessed data?
Yeah, for frequently accessed data, there's kind of it really boils down to making it available in something faster. And the ultimate
Mm,
is RAM. So when you
okay.
have stuff that is a small amount of data that's frequently accessed, you can usually just throw more RAM at it. So if you're reaccessing a bunch of data and it's under a terabyte of space and you've got a sizable cluster, it's going to actually hold all that data just straight in RAM. So once
Yeah.
it's read once from whatever the slower underlying media is, whether that's platter or flash storage, it's just going to instantly be there. But we can also set up tiering where the data as it's accessed will move up into flash storage. So if they're using platter or hard drive based storage for the bulk of data and it's using say erasure coding and it's taking a long time to go access the data because it's being frequently accessed from the platter and there's not enough room in RAM in the cache, then we can use SSDs to basically act as a secondary tier. But categorization of the data is just again super critical. And one of the funny things too is that erasure coding actually speeds things up when we're talking about write performance. So when
Okay.
you're ingesting that data for the model, as just like the small files, like the 1K, 4K, those really small multi kilobyte files, you want to have triple replica and put those into flash storage. It's really important to put the big stuff into something that's erasure coded because you actually get a bump in performance. And it makes sense because with erasure coding, you've got maybe you're not having to write the multiple copies. You're computing these coding blocks, and so you'll have if you chunk things up into eight, as an example, 8 plus 3, that means eight, every block is going to be carved up into 8 data chunks. And then you'll have 3 coding chunks to protect it. So that means that out of the total of 11, you could lose any 3. You could lose 2 data and 1 coding or 3 data, and you can recover it all. But you're only then storing the data an extra, the fraction would be, 3/11 is your wasted space, but effectively, you're getting way more usable capacity and you're not having to write the data multiple times. Whereas replica, if you upload a terabyte, you end up having this big, what's called write amplification. And so you
Okay.
ingest 1 terabyte, you're having to write 3 terabytes on the back end, which slows down everything because now you're having to use that back end network to re-replicate these huge things. And so that's where the strategy of take the small things and have a strategy of storing 3 copies and take the large things and make them erasure coded. And you can even design these systems to have not just 2 different layers, one erasure coded and one replicas, but you can have different styles of erasure coding like 4 plus 2 and 16 plus 4. So you can take the stuff that you're not going to access, maybe once in a blue moon, and put that out to like something 16 plus 4, really long stripe, perfect for big files, and then you don't have to worry about wasting a lot of space for the coding blocks and stuff like that.
Yeah, you have to be really smart to understand erasure coding, right? Because there's a lot of science that goes behind it. And as far as keeping data in sync and keeping data online, and if something happens to any bit or byte of that data, then things are able to be recreated or they're not lost because of this algorithm that happens on the back end. So I can see where erasure coding is very, very helpful. But let's talk about, let's look into the future a little bit. Let's look ahead. And I want to see what you are seeing for storage overall as far as artificial intelligence and machine learning is concerned around the evolution. And also, what are your plans that you have to meet some of these demands for AI and ML?
Yeah, the I'd say the one of the biggest areas that the companies I think are addressing right now is quality of data coming into these models. They There was an interesting report that came out recently where they were talking about how companies, or I forget, it was one of the major clouds, was doing some testing. They threw a whole lot more hardware at a particular problem and got a 10% boost in overall quality of the model. And then they took a different approach and they said, well, what if we just made the data quality better? What if we cleaned it better, made sure that the model was being trained on better data? And that was like 1,000x better results. And so it seems to me like a big part of artificial intelligence going forward is going to be in those earlier stages. Companies cleaning the data, using their systems to improve that stage of the process because it's so critical to have it in good shape, have super high quality data before it gets fed into the model. And so I think that the object storage and NAS is going to play a significant role in that, and also just in general being able to find cost effective ways to store all that data as these models get bigger and bigger, because
Mm,
nowadays your critical asset for AIML is your data. And that means that you need to
right.
hold more and more. And today that might be petabytes, next year, you know, exabytes, who knows, it depends on how
Yeah.
much data your particular business or organization is collecting, and being able to process that quickly and store it in a cost effective way, I think is super important. And that's why we've been big supporters of open source. And that's why we use
Yeah.
Ceph
Yeah.
technology in Quantastore, because we look at it as a strategic risk to organizations that are using proprietary file systems and object storage technologies, that when you're at an exabyte scale, you just don't want to be beholden to something proprietary. It's just there's too much risk involved with that.
So you mentioned data quality. Data quality is very key nowadays, especially the integrity of that data. And you know that I'm in backup and recovery. So the integrity of data, testing that data, making sure is very key to being able to. The main purpose of backing up data is to recover that data in case you have some type of mishap, right?
Yeah.
Now, I'm sure you have several, or maybe you do or you don't. Do you have customers actually leveraging your Quanta Store system with large language models actually running on your system?
Yeah, there's another deployment we're doing just this here in a few weeks, where we'll be processing billions of emails with
Mm,
a
okay.
large object store. And those kinds of workloads, again, that tagging of the data, basically assigning what's called a stored class identifier on it. Like, you can tag it for
Okay.
performance versus standard. Everything's kind of modeled in object storage after Amazon's S3. And so Amazon defined the default as this storage class called standard, and then they created other
Okay.
ones like Glacier. Everybody's heard of Glacier. That's just
Right.
another storage class tag. And we basically use that same kind of methodology of being able to make different pools, different kinds of storage within the object store, and then dynamic tagging and stuff like that to organize it well. But yeah, backups are critical, and backing up the object store, is also important. You don't want to have one copy, and so you need to figure out a way, either putting it all on a big, tape library, or
Hmm.
replicating that object storage cloud to another one. And that's been another area where we've been investing a lot of engineering. So this upcoming version that ships here actually in a week, end of next week, has the ability to set up multiple clusters, and basically set up multiple zones, if you will, and link those together. So you could have one in Atlanta, one in Seattle, and one in Dallas, and it will dynamically sync between all three. Now, if you have an
Hmm.
outage, your whole model doesn't go offline. And I think that's another thing that's super important as well, is as these models go into production, you need to take all those practices that you and I have talked about, around business continuity plans and all of that,
Yeah.
and apply it to the AI system. Because if the AI system's doing your call center, if the AI system's taking care of, some critical healthcare type of workload, those doctors aren't going to just say, "Hey, you know, let's reschedule all the patients for a week out," or whatever. I mean, there's a huge amount of costs associated with that. So I think replication of these object stores is also just such a critical element of this, because of the need to have these models online at all times.
All of that is really critical.
Yeah.
And one thing that I want to have a conversation around cost, right? Because cost management and being more efficient with storing your data, and I'm sure there's a method to the madness of how you store the data as well, and some of the things that are being done behind the scenes with your technology. How important is managing the cost, and how crucial is it in especially deploying some of these large scale solutions like yours? And how does it help with balancing the performance and the capacity needs and also the cost? Is
Yeah, for sure. In general, as the systems get bigger, they get more and more cost effective. And especially with scale out systems like the object storage, what's really hard to do is get something cost effective that's small. When you're talking about building something that's under a petabyte, you still need to build out 6 to 8 beefy servers to go run the object store. And so it it's becomes more and more cost efficient as it gets bigger. And what we
okay.
do with, we have various ways that we do our licensing model, at least on the from the software perspective, to make it less and less expensive as the system gets bigger.
Hmm.
But on the hardware side, there, you can make use of a mix of flash and platter in smart ways to offload that data that isn't going to be accessed as frequently. Like if you're doing a backup of a bunch of data that isn't going to be used by the model anymore, but you need to keep it. Maybe
Yeah.
it's the data that has been, before it's scrubbed, like the raw data that before it gets prepared for the model, that you
Hmm.
could store onto hybrid storage, which is a mix of flash and platter, and do that much more cost effectively. And so we end up doing a lot of deployments that are a mix of both scale up object stores and sometimes scale up NAS, and just kind of fit the storage solution to what the customer needs for the workload. But yeah, I think Platter is going to be around for a while now, and I think it's going to continue to work towards, replacing more and more tape, being more and more cost effective as a tape replacement, especially as
Hmm.
Seagate and others start marching towards, 40 and 50 terabyte drives, which are just around the
Yeah.
corner. The 30 terabyte Mosaic 3 drives are out now, which is exciting, and they're just getting uh, super amazing costs, in terms of their cost effectiveness. So Platter's not going away, but I'd say definitely for the live models and, the main processing stages of AI ML workloads, the bulk of that is becoming more and more just pure flash NVMe object stores.
What's the next level of storage? I know we have SSD, flash, and NVMe. What's on the horizon? Is there something else out there?
The thing I'm really excited about is the QLC drives. You might have seen in the
Mm,
news, Solidigm announced the 60 terabyte NVMe drives. They're
okay.
solid state drives, but there's some interesting technology changes with it. You remember when, like, hard drives for the longest time had a 512 byte sector size, and
Right.
and then the 4K native drives came out several years ago, and everybody was like, okay, how do we format these, and are they going to be as efficient? Well, with QLC, this is the drives that are 60 terabytes and larger. They have to use a bigger block size, and so instead of 4K native, it's 64K native. It's getting 16 times bigger. So these
Yeah.
new NVMe drives are not good at writing really small, like 1K, 4K files. They're wasting a
Hmm.
ton of space when
Wasting
you do
space.
that.
Yeah.
Yeah.
Hmm.
So We're excited about that in the sense that some of the technology that we have around the auto tiering lets us dynamically look at what's inbound and say this one's good for the QLC tier. We'll send it that way. This is really small. Let's put this on the TL storage pool. So we're already building or have built that tech into QuantaStore to kind of like deal with different types of flash because they have different pros and cons to using like a QLC versus a TLC type of quad level cell,
Okay.
a flash device versus a tri level cell. So yeah, it's
Okay.
exciting.
Yeah.
I think
Awesome.
all the manufacturers will have a 60 terabyte drive out before long, and then it's going to be bonkers because there's be a 120 terabyte drive out probably not too far into the future.
Did you see the previous episode that I did? I think it was a couple back. Ceramic storage.
Yeah,
Did you hear about
it,
that?
I heard about a glass storage, but yeah, tell me about the ceramic one. Is it like last a
So
thousand
it's
years or something?
it's supposed to last close to infinity, right? So you're talking thousands of years, and the way that they write it, it's pretty phenomenal. So that's about all I can say because the technology is that they're still building on the technology, and you have to go take a look at the episode so you can get up to speed on all of the information about it though. But there's
I,
also DNA storage and as well. I'm sure you've heard of that too.
the DNA storage,
Yeah.
yeah, yeah. Isn't that funny? I mean, if it's going back to ceramics, it's like what's old is new again. I mean, we're now ancient history, everything was carved into stone tablets and chiseled into walls, right? And it's a bit full circle, but it's a good proof point. I mean, those those things from antiquity are still readable and still good, and being able to do that at sort of a nanoscale, microscopic scale, I think is a great idea. There's so much data out there on the internet today, and it's so vulnerable. We think, okay, it's in object storage, it's in the cloud, but there's all kinds of various things that events that could cause massive data losses in those clouds because of the what was it, the Carrington event, the one where
Mm.
we had a big solar flare and it wiped out a bunch of
Oh
telegraph
yeah, yeah,
lines back
yeah.
in the
Okay.
1900s. There's all kinds of funny vulnerabilities like that, and so it'll be great to know that things are getting stored into like tablets of ceramic or DNA or something that can't
Yeah.
be destroyed, so that the generations hundreds or thousands of years from now will have a proper recorded history of the time we live in. So
Yeah. So one more question. We're talking, you mentioned generations to come. So I have quite a few college students, computer science majors listening to Data Protection Gumbo. And our technology, there's thousands and maybe even hundreds of thousands of little niche disciplines that you can go down a rabbit hole on and become proficient on. So cybersecurity is one. Also, you have artificial intelligence and machine learning. So those are like the three top hot specific disciplines, right? Within IT. What advice would you give to a college student right now, junior or senior, right before they get ready to enter the market? What advice would you give them to start doing right now?
yeah, I think all those things around learning how to use these models, they're just out there. There's all kinds of free resources. We have Meta to thank for that. They put
Mm,
their model out into the open source. And so definitely become skilled at, using those models. I would also recommend that kids learn Rust and C++ and those languages. There was an announcement, that the president put out this last week saying, "Hey, there's these critical vulnerabilities in languages like C and C++."
right. Mhm,
I'm a
mhm.
huge fan of C++. I've been writing it in that language for 30 years, but I would recommend to kids coming into the industry learn Rust because there's just going to be a huge demand for like ultra secure software, that has all the memory bounds checking and stuff like that that language has. And I think what we're going to see is more evolution of the C++ language to make it
Mhm.
as safe as Rust over time. So I think that both of those
Yeah.
are good languages to learn, but really, I think dig in on those languages like Rust, because I think there's going to be a lot of code rewritten in that and tons of opportunities for people that have those skill sets.
Okay, awesome. Let's begin to wrap up here. And I do appreciate the time that you have taken again to enlighten the Gumbo audience with details and information around AI and ML and persistent storage, and just being able to get access to large amounts of data really quickly, the right way, the most efficient way to store that data, and how to be smart about architecting a solution that you need once you need that data to come back like really quickly and like super fast speed. So, one more thing as well. So, how can someone get in touch with you? Is that LinkedIn or your website? What type of information that you would like to leave for someone if they need more information around OS Nexus?
Yeah, send me a LinkedIn invite. Just say that, watch the podcast, the Data Protection Gumbo podcast with Demetrius and I, and send me a LinkedIn invite. And happy to help you with any questions you have in the area. We have, on our website as well, we have a community edition of OS Nexus Quantistore, so you can get it for
Mm-hmm.
free and build an object store. And if you're working on, learning how to set up object storage for a model, we have a free edition of the software you can use to totally set all that stuff up as well. So yeah, LinkedIn's a great way to reach out.
Okay. And how long do they have access to that community edition, that free edition?
It's free, yeah. The license is for 2 years, and you can renew it anytime. And we just up the capacity to 80 terabytes, and you can have a 4 node, so like a 320 terabyte cluster with it at no cost. And there's some great YouTube videos that we've got on how to go set up the software. But yeah, it's a lot of fun. Super easy to go set up. You can just kind of follow along with the YouTube video.
And are you running that software at home to back up all of your data?
No, I'm at home. I've got like the workstation and the laptop. It's super simple.
All right.
I've got
Yeah.
all my friends have their own NAS boxes at home and do all
Yep.
kinds of fancy stuff. But for me, it's just super simple.
Yeah, I remember when I lost a hard drive. This was an external hard drive. I lost all of my data.
Oh
And I'm a
no,
backup guy. So,
yeah,
and it's like, you know what? I need to drink my own Kool-Aid. So I made sure that I had an extra drive, and I did my backups on a daily basis, and I check them and make sure that they are successful. So, all right.
yeah.
Just wanted to thank you again. And before I end, everyone, please check out the Backup and Recovery Professionals LinkedIn group that I run. There are 25,000 plus storage and cybersecurity and data protection professionals in that group. And we're having great conversations similar to the ones that we're having right here on Data Protection Gumbo. So, Stephen, thank you once again for being a guest.
Thanks for having me on, Demetrius.